So continuing on, we have learned how to use aggregate functions and queries to perform calculations based on the whole data. So we know how to get the average of something, the minimum, the maximum, the total of something, or the sum, and to count how many records there are. But there are other calculations that you can perform in a SQL query. And a great example of this in this particular database is in order item. Now, if you look at order item, what this says is that this order has ordered this item. They ordered one of these at 300 apiece, and they paid 300 total for them. So, this particular item, in order 2000, ordered 4 of them at 50 apiece for 200 total, which makes sense because 200 is 4 times 50. So the formula we're working with here is quantity, stupid low font. Yeah. Quantity times price is equal to extended price. So if I order 5 $1,000 items, the extended price would be $5,000. Now, this is stored in the database here, but it really shouldn't be. And the reason is that we can get the database to give us this number. We don't need to store it. As a matter of fact, to store it can introduce some other data integrity issues because this number can be changed. I can say he bought 4 $50 items and he paid $150 for it. Well, that's not correct anymore. So did he actually buy 4 of them? Did he pay 200 after all? Did he really just pay 150 and get one of them for free? It becomes very confusing. So what you can do to get the database to give you this information, I'll make an example and we'll pull quantity, price, and extended price from order item. So let's do that. Select quantity, price, extended price. And remember, if I'm going too fast, feel free to pause or go back. Follow along with me. This is going to be very helpful if you follow along with me. So, quantity, price, and extended price from order item. Whoops. SQL is not case sensitive, but I'm kind of anal about these things sometimes, so there it is. We run it, quantity, price, and extended price. And the formula we were just working with should tell me that quantity times price is always extended price. And if you look at the data manually, you can see that's the case here. Well, and I told you we don't need to be storing extended price because we can get that from the database. Well, let's check this out. I can select quantity and price, and I can actually perform a calculation and select that as well. So I can say select quantity and price, and then quantity times price. And what this will give me is 3 fields, quantity, price, and then this expression will be calculated based off of the data. So let's see what happens. Quantity times price, and then the third field, it gives me quantity times price. Now, it's given it to me as expression 1002, so that's where that as keyword comes in again. As total cost. I preferred that to extended price because I think that makes more sense. Quantity, price, total cost. And this value is not stored in the database. We told the database to calculate this for us. We wanted to know how much the total cost was. And as a matter of fact, later on what you'll learn when we get to joins is that we don't even need the database to store the order total in retail order because we can tell it to go back into order item and total all that mess up for us. So this is an example of how you can perform a calculation based on the data that's stored to reduce redundancy and risk of data corruption. So